The next keynote is in fact going to be focused on DC fast chargers, and in particular how the charging stations can seize opportunities to boost their success. We're very pleased to welcome, once again, Chief Sales Officer and President of Europe at Tritium, David Nicholl. David, hello. Welcome.
Thank you. Hi everyone, good afternoon. This is day 2. I hope you're all full of energy after your lunch. Back in the UK, we call this the graveyard shift. It's when everybody comes in with full stomachs and starts to fall asleep. So I'll try and give a bit of energy in the room, okay? So as said, I'm going to discuss the fast charging for the future, scalable solutions to meet the global demand. Yeah, my name is David Nicholl. I'm the Chief Sales Officer for Tritium. And before we start, I just want to give you a little update for those people who don't know who Tritium is. So Tritium actually has been present for over 21 years. It's had a team that started off building solar racing cars. It also developed the first, developed battery management systems for James Cameron's Deep Sea Challenger mission to the bottom of the ocean. It also developed the first IP65 DC charger, liquid cooled, the first in the market. And now it continues to develop fast chargers which give capital efficient solutions. So we built so far over 7,400 plus chargers. We've have got 3.6 million charging stations. And we know this because we connect to each of our chargers in the market with our Pulse software system, which allows us to analyze all the data, utilization rates, power, sensors. It also allows us to diagnose any faults and even get the charger up and running again. We're in over 41 countries and we continue to expand. We've launched on the NASDAQ stock exchange. Also, we were presented by President Biden in the Made in America and obviously for the National EV Infrastructure Program, the NEVI program. And we have 3 facilities, one in Brisbane, Amsterdam, and America. And we've just opened our new plant in Tennessee, where we're looking to build over 10,000 to 30,000 chargers per year. So when you think over the past X number of years, we built 7,400. Now we're going to build that number every year and continue to expand up to 30,000. So we have 500 plus staff, and again, when we maximize the capacity of the factory, we'll have over 1,000 staff. But no matter the challenge, no matter the adventure, the Tritium team are totally motivated constantly to innovate and move forward, and we're motivated to continue to electrify transportation. So what does the EV charging market look like in the future? I'm sure you've all heard lots of very varying statistics. I'm going to share some. The Europe BEV market sales in 2021 was 10%, and that was growing at 53% year on year. The global sales in 2030 is predicted to be 2 out of every 5 cars, so that's 20%. The European car sales on 2035, 100%. And the European aim by 2030 is to have 10 EVs per public charging point. So there are some EV misconceptions. One size fits all. Every vehicle charges at the same rate, which of those of you who are in this industry know that there's different charging curves. And all technology is scalable. All modular systems are created equal. And my favorite one, the more power, the better. We've all heard that everybody wants bigger and more powerful chargers. But let's look at the charging curves. So, is it right when we say the more power, the better? Let's look at the demand. It's actually the car that controls the speed of the charge, not the charger. Not all vehicles charge at the same rate, and on the graph we can see the Audi e-tron, the Porsche Taycan, the VW ID4, the Tesla Model 3, all with different charging rates. So we also know that most people come and charge their car because of range anxiety between 30% and 75%. So after 30%, if you look in the curve, the majority of cars today on the market, 150 kilowatt satisfies that. So there's a lot of available power. When you start installing from 150 upwards, it means that you're on use capacity. So we need to rethink the power delivery at the charging station. So the current state of play is that everybody's trying to provide the maximum power demand. And really we need to think about the future state. This approach on the charging sites will focus the application mindset based on profit. So here, how do we achieve this optimal operational excellence? So if you use a 1-to-1 ratio, so you have a 150 kilowatt charger, and you have a car that demands 50 kilowatt of charge, you have 100 kilowatts of unused capacity. So let's look at this example here. So rather than looking at a 1-to-1 ratio, we're looking at a 0.67 to 1 ratio. That means a rectification unit at 300 kilowatt and 3 150 kilowatt chargers. And people used to say to me, well, mathematically that doesn't add up because that makes 450. How does that work? Well, we'll show you in a minute. But basically, you've got 3 cars that come along to this case, this use case. We've got a Nissan Leaf, and the charge curve is around 50 kilowatts. We have an Audi e-tron, which charges about 150 kilowatts, and the Tesla Model 3, which starts off slightly above 150 kilowatts, but gradually goes below that. So if you look at the graph at the bottom, you can see, let's say the cars don't all come at once, and the first car comes in, it's a Tesla, it starts charging. It can only charge at 150 kilowatt on the first charging station. Then the Nissan Leaf comes online and starts charging, and then finally the Audi e-tron. So if you look on the right-hand side, you can see that with all 3 cars charging, connected still to 150 kilowatt charger, there's unused capacity. So you need to design things for the optimal charging solution, which also means that we want to make sure the user, the driver, has got the right kilowatt ratio. Also the dwell time. We talked a lot about as well the idle time of the driver. They don't want to wait too long for the charger. And the charger availability. So we want to make sure there's enough chargers. And you know, drivers actually prefer lower power instead of longer queues. So they would rather have a 50 kilowatt charger, or more of them, than a 300 kilowatt charger, which with only 1 car there. So the availability of chargers is better than a fewer high-powered chargers. So what we've done is we've designed with scalability for a greater EV adoption. And if you look at the top, this is the 1-to-1 ratio which you can install. So you've got a rectification unit at 300 kilowatt. You can have 2 charging stations at 150 kilowatt, a 1-to-1 ratio. You can then have a mixed power ratio, which is 300 kilowatt, and a 50 kilowatt, 100 kilowatt, and 150 kilowatt, adding up to 300 kilowatt. Or a high availability one on the right-hand side, which is 50 kilowatt, and 200 kilowatts. Very simple. But if you want to upgrade you can actually, with the high power, where you want the 150 kilowatt charger fully maximized, you need to add another rectification unit to give you 600 kilowatt and 4 150 kilowatt chargers, which is 1-to-1. But actually what you can do in a mixed power is you can actually install more DC to DC units and therefore increase the capacity of the charging station, but not the need to require a new rectification unit. And here in this example, we're increasing one of the charging stations up to 100 kilowatt. And then if we look at high availability, this is where we've got a 300 kilowatt rectification, and we've got 4 150 kilowatt chargers, which means that the ratio is 0.5 to 1. So we've got more charging stations, the ability to charge at 150 kilowatt per car, or 2 cars at 75 kilowatt, so in total 8 cars. So our message is that really you want to scale for today, or size for today for the market, for the cars that are on the market, which as you see, some of the Nissan Leafs are 50 kilowatt. But then you can scale both inside the charging station and also adding more rectification units or adding more charging stations. This is done by using a DC microgrid as well, which allows us to reduce the installation cost because the cabling of a DC cable is much smaller than an AC cable, up to around 50%. And it'll also, with this model, it allows us to exceed the grid limits because our rectification unit's 300 kilowatt, yet we have 600 kilowatt of chargers. And it's using our proven field modular components. So that's it from me. Thank you.
Thank you very much, David. Once again, reminder, please do send us your questions or comments via the app. You know how to do it. Don't be shy. And in the meantime, I have just a couple of questions that...
I hope they're not too difficult because just so you know, this is day number 9 for me in Tritium. So
you're very, very fresh.
Very fresh.
But that's good.
Hot off the press.
But that's good. A fresh perspective is what this industry always can benefit from. So we had a question about how you would determine which site configuration is best for each use case. So does that question make sense?
Yeah, how we would determine which size of charger to use?
So if it's going to be like high power, mixed power, high availability, so how do you make a decision about the type of site configuration that makes sense depending on...
Yeah, well, I mean, obviously this is predominantly for our customers, our charge point operators, who should be deciding where the location is. But normally, when you look at it, if you look at a retail type customer, part of it's to do with dwell time as well, because customers want to go into the retail customer wants to keep the client, the driver, in the shop for a long period of time, so they don't want to charge too fast, just enough time so they can shop and have coffees. So normally the kilowatt rating you want slightly lower in the retail market. If you're looking at highways, motorways, then normally people want to charge very, very fast. They're stopping off, quick coffee, and doing that. So then you look at other cases about the car size as well that we were just talking about, that you might need mixed chargers depending on satisfying those cars at 50 kilowatt, some of the other cars at 100 kilowatt, or other cars at 150 kilowatt. So we don't actually look at all the statistics because this is the job of our charge point operators to choose those sites and those locations. We're able to, with our modularity, scale and adapt our offer to the charge point operator.
Okay, thank you very much. We had another question that was sent a bit earlier, and someone was asking, how do you exceed grid limits with your PKM architecture?
It's a secret.
It's a secret.
No, I mean, obviously, it's to do with the way we do the rectification and then the load management system through our software. That's all I can say.
Okay, the secret will remain. Do we have any questions that have been sent in via the app? Not yet. We are a tiny bit ahead of schedule, so if nobody in the audience wants to spontaneously yell out a question for David, here's your chance, going once, going twice.
Have a break and get some ice cream.
You can go out and get some ice cream. Ladies and gentlemen, then thank you very much indeed to David from Tritium, his 9th day in the job. So thank you very much indeed.